Welcome again to lesson 2. We talked about the basic concept about vector quantities and scalar quantities. Now in this lesson we will talk more abruptly or more briefly about vector quantity. So let's start with vector. So we told you what vector was in the previous lecture, that let's say I went from a point A to a point B, and from that point B I went to a point C. So what will be my displacement here? So the displacement of myself would be the R. Let's say this is my displacement. So when we went from A to B in a particular direction, in a particular magnitude, so we know that there is a magnitude present here. So there is a magnitude present. We're also quantifying a direction. So this line here is a vector, and we can say it's vector A. So this sign over here, it denotes a vector. This sign, only A, is just a magnitude quantity. It doesn't identify any direction, but when I add an arrow sign over it, it identifies it as a vector. That means it has a direction and magnitude. But we can also do this. We can add a modulus over this, around this, so it turns into a magnitude, because now the direction, we generally describe directions by positive or negative, but the positive or negative here will just cancel out, and it will just be the magnitude right here. So when we do this, or when we do this, we're denoting that this is the magnitude. And when we're only referring to this, we will say that it's the vector quantity. So that's pretty much the quotation, the notations. Now let's say the line AB, we already knew that it is a vector because it goes in a particular direction and it has a magnitude. Also, it is true for this point also. So let's say this is the point B vector. Now the R, it is also a vector, right? Because it is going in a particular direction from A to C. So R is also a vector. Now this is how we work with vectors. So let's say the figure was not like this. It was not like this at all. Let's say I had a A which was scattered around here. This is my A vector. And we also have a B which is, let's say, scattered around here. So B. And my question is to you to determine what is the displacement if A is a distance and B is also a distance. So of course the displacement will be to add the two journeys. Let's say these are two journeys. This is a journey 1. This is a journey 2. So we are talking about two particularly journeys. So each journey started from this initial point and ended at this end point. The journey of B also started from the initial point and ended at this end point. So what will be the journey of our whole displacement? The journey of our whole displacement would start at A starting point. It will not end at A's ending point, because at that point we're also starting the B. So that's actually the same point. So the ending point of our displacement would be the ending point of our last journey or our last location. It will be this. So let's just join this together. And the fun thing and the most precious thing about vectors, that you can shift it. What is shifting? Let's say we're around here with A. We can just take this A and we can place it just around here. The magnitude is the same, the direction is the same, so the vector will be the same. There will be no change at all. So unless you're changing the magnitude or changing the direction, you can place it anywhere in this plane, anywhere in the graph, and it will not cause a problem. That's the best thing about vector. They are not mad, they are easily handled by us. Great handling, it is great. Now we can also move this B. So let's put the B just around here, so it's the same direction and the same magnitude. Let's say it's the vector B, and see what we did here. So that was the initial point of A, that was the end point of A. Right around here it was the initial point of B, and this was the end point of B. Now watch carefully that this point right here is both the end point of A and the initial point of B. So we'll just say this is the midpoint. Okay, this is the meetup point. So how will we find the displacement? It's just very easy. We just join these two lines, and so the initial point of our first vector and the end point of our last vector would be our resultant vector. Resultant vector, or in this case, if A and B determines distances or displacements, as two displacements, so R will be the resultant displacement. Okay, so we can use it in different applications in our life. We also study different forces. Let's say there's a box right here. Okay, there's a box right here, and someone applied a force of, let's just use a variable here, the F1 vector right over here, and another thing, it applied a force right along here, that is F2 vector. Now the question is, what will be the resultant or the net vector F? What will be that? So I told you the magnificent thing about vector is that they can be shifted. They can be shifted anywhere. So if we think of this box as a whole point, as a singular point, so we can say that this point right here, to that point, the F1 force is acting right over here, and the F2 force is acting right over there. Now you can shift this F2 and we can bring it up. So that's the same F2, we just brought it upwards. Okay, just like this. Now what is the resultant? The resultant is this line over here. This is the F neat. Now what is the F neat working at? So we can also now take this point and shift it right over here. So when you shift it right over here, let's say that is the F neat. So let's say that there's a lot of shifting of the vectors, and that is what it is magnificent about vectors. You can shift it and you can locate where the object will be going. So the object will be going, we can say the object will be going right around here, F neat. That is the most magnificent thing about vector there is. And this is the basic knowledge about vectors. In the next lesson we will know about the parallelogram laws and the triangle and the basic stuffs, but we'll just not look at the law, we will know the theory and the concept of that law. So till then, stay tuned.